In this lesson, we're going to find the average value of a function. In our first example, we're going to find the average height of the paraboloid z equals x squared plus y squared over the square where x goes from 0 to 5 and y goes from 0 to 5. Let's start by drawing the paraboloid. Here's our z-axis, and here's our y-axis, and here's our x-axis. So let's label this x, and we'll label this y, and we'll label this z. Now our area, our square, is going to go 1, 2, 3, 4, 5 units in the x direction, and 1, 2, 3, 4, 5 units in the y direction. So from the origin to 5 in both the x and the y direction. So let's draw the area. Here's the area right there. Now, if we extend this just to sort of visualize the paraboloid and brought this all the way up, we have a larger square which is a 10 by 10. And now let's draw the paraboloid. The paraboloid is going to start at the origin, and it's going to basically be just a point. But when you get to z is equal to 1, we've got a circle in the xy plane. Let's draw that circle, which is going to have a radius of 1. So it would look something like this. And we get to a height of 2, we're going to have another circle with the radius of 2, which is in the xy plane. These circles are all parallel to each other, and they're also parallel to the xy plane. Here we have, let's see, 3, 4, 5. So we're going to go to a height of up to 5. And a height of 5, at a height of 3, we come out to a radius of 3. So there's our next circle. And then at a height of 4, we have a radius of 4. And then finally at a height of 5, we have a radius of 5. It's a freehand, but what we end up with is it looks, this paraboloid over our rectangular area, and that is if we looked at our 10 by 10 rectangular area, looks like a cone. So I'm going to draw the cone over here. Let's see, we'll draw the cone here. So here's the cone, and this cone has, it's sort of cone looking. It's actually a little bit more curved, and it has a height of 5 units, and it has a radius of 5 units. But we're only talking about a quarter of the cone, which is this. In fact, we maybe come out this way. This sort of shows us a quarter of a cone. So that's what we're looking at, is we're looking at the quarter of the cone. So the quarter of the cone is just the piece that's over this area right here. So let's move this diagram up. And what we want to do is to find the average height. We use the formula 1 over the area times the volume. And the volume is the volume over that area. So we put on our integrand is the function, which is the paraboloid. And we integrate with respect to x and then with respect to y. And x is going to go from 0 to 5. And y is going to go from 0 to 5. So we have to work this out. So I'm going to move this over here. Now over here in blue, we're going to say the area that we're talking about is going to be the area where which is the square formed by the values from x equals 0 to x equals 5 and y equals 0 to y equals 5. So the length and width are both 5, 5 times 5. So the area that we're talking about is going to be 25. Let's move that up here. That's the area that's right here. And let's move that down there. And so I'm talking about the area of that square. We get now 1 over 25, that's our a, times the outer integral from 0 to 5. And if we integrate our inner integral with respect to x, our antiderivative of x squared with respect to x is x cubed over 3. And our antiderivative of y squared, we treat y squared like a constant, so it's y squared times x. Or I can just say y squared, and that's going to be multiplied by x. And all of this will be evaluated from 0 to 5, and its result becomes the integrand for the outer integral. So now what do we have? 1 over 25. Again, the outer integral goes from 0 to 5. And if we plug a 5 in, we get 5 cubed over 3 plus 5 times y squared. So that's our new integrand. And we integrate with respect to y. And this becomes 1 over 25 times the antiderivative of 5 cubed over 3 is 5 cubed over 3 times y plus 5y squared cubed over 3. And this is evaluated from y equals 0 to 5. And this gives us 1 over 25 times 5 cubed. Well, 5 times 5 is 25. So let's make that 25. That's for the 5 cubed. Times 5 is the 5 cubed. And then we put a 5 in for the y. And that's over 3 plus 5 times y cubed is 5 cubed. So I'm going to say there's one of the 5s and the other 5 cubed is 25. I'm trying to factor it out so that we can see that we can cancel out the 25s. And so what we get is 1 over 25, the 25 is gone. So we get 5 times 5 is 25 over 3 plus another 25 over 3. And of course we have a common denominator. So our answer is 50 over 3 units. That's the average height, about 1/3 of 50. Or 1/3 of 50 exactly.